Okay, this chapter is called Dynamics of the Large-Scale Monsoon. So it is split into two chapters. The next one is called Coupled Monsoon System, where we will look at many more details of the dynamics of the coupling of the heat transport, moisture flux, etc. Here we will just look at observations, theories, high frequency variability, and we'll touch on summer and winter monsoons, mostly focused on the South Asian monsoon, but we will also touch upon the Australian and African monsoons. Okay, complexity of South Asian monsoon is described rather poignantly by J.A. Young. Actually, if you dig through the Indian prose and poetry and mythology and scriptures and so on, monsoon is a big theme throughout. The dramatic onset, the heavy rains, there is music that is related to the monsoon, there is prose, poetry, movies, and so on. So it's a very dramatic thing for the country, obviously. Coming back to Young's description, physically, the monsoon system is a complex of seemingly disparate parts, two fluids, the mobile air, and the changing ocean below. Deserts and areas of torrential rain, the dramatic seasonal progression of winter to summer, winter and summer hemispheres linked by strong wind and ocean currents across the equator, mountain complexes that assist and inhibit rising air motion, water evaporation and condensation, clouds that alter most properties from wind to radiation, cyclones that grow over the ocean and drive deadly surges. Okay. When monsoon is discussed in most of the literature, the onset, the withdrawal, length of the rainy season, and so on are kind of key features that are discussed. But in this chapter, we will not talk about the onset, the withdrawal, but we will talk about the active break periods. And we already talked about interseasonal oscillations in terms of MJOs. Here we will talk about mesos and some of the theories about mesos. This nice figure gives us a good sense. So the country is typically divided into these kind of regions. There are many ways to do it, but the India Meteorology Department does it as homogeneous regions. And the surprising thing is that no matter what time scale you look at, there are distributions at spatial scales that are not very well understood. How does, for example, monsoon trend over multiple decades can be different in two small neighboring regions. So this goes back to the idea of the seasonal distribution of the rain itself. It is always very spotty, almost like India is a popcorn kettle and you are warming it and then popcorn kernels are popping randomly everywhere, and over the season you still end up each year with different looking distributions. Obviously makes it for a very difficult forecast problem. What is quite obvious is that if you look at the evolution of rain over the year, you can see that the summer monsoon is a well-defined season with some regions getting northeast monsoon as well, which we will touch on later in this chapter. So this is just a climatology of 1901 to 2007, but this is basically the picture. So you can see the northeast monsoon has earlier onset, similar to the Bay of Bengal, and then you have more systematic evolution over north central region, which has peak rainfall in July, August, and typically the onset happens in end of May, early June, so the onset days vary by a little bit. Withdrawal dates are not as dramatic as the onset, as you can see here. They're much more widespread, and a lot of the interannual variability of the monsoon tends to be associated with the withdrawal phase, which relates to the impact of El Nino, the Indian Ocean dipole, and the Atlantic Nino, and maybe even the higher latitude forcings from the North Atlantic and North Pacific, as well as potentially from the Southern Hemisphere. Okay, so the country is used to this wet period seasonally and dry periods for much of the rest of the season, so that makes it for a very unique problem in terms of managing water, food production, etc., and of course the associated agroeconomics and other activities. This is a nice figure by Bill Lau, which has been used in various documents like the World Climate Research Program's CLIVAR program, that is called Climate Variability. Now it's Climate Variability and Prediction. It has continued now for a couple of decades, which coordinates worldwide climate prediction, modeling activities, and so on. So this is essentially looking at climate, monsoon climate as the annual system being connected to the fast system, as he calls it, where intraseasonal variability that we have already talked about, which includes MJOs. We looked at the OLR variance, for example, from days 2 to 10, 10 to 20, 30 to 60, and then lower frequencies and so on. Then there are internal atmospheric processes, which means they are the kind of the atmospheric noise, if you will, and they are not coupled to the ocean so strongly, which means there is no strong modulation, which raises prediction issues as well. Then there is the fast-slow system with the adjacent oceans, some of which respond fast, like the SST response to the fluxes, or the Ekman transports and the freshwater fluxes, ocean hydrology in terms of salinity, and land processes, moisture recycling, soil moisture, land vegetation, snow cover, and so on. And then there is the slow parts of it, which include the tropical, extratropical interactions we have talked about, and we will revisit here. Tropical, extratropical interactions coming from both the fast system and the fast-slow system, with the slow system being the global influences like ENSO, the tropospheric biennial oscillation, interdecadal variability, which begins to relate the monsoon to, for example, the Indonesian through flow as the ocean tunnel, and atmospheric bridge from the Pacific decadal oscillation or the Atlantic multi-decadal oscillation, North Atlantic oscillation, southern annular mode, and so on and so forth. Okay, so let's leave this podcast here and then come to some unique features of the monsoon in the next podcast. But as a setting, we are going to start with this dramatic South Asian monsoon focus, but we'll also go into some things that are unique to this system, especially when compared to the African and Australian monsoons. East Africa itself also has a monsoon season, the longer one when the pre-monsoon of the Indian monsoon happens March, April, May, and a shorter one when there is a transition from the summer monsoon to the winter monsoon over India in October, November. So they have the long and short rainy seasons, which we don't talk much about here, but we will talk a little bit more in the next chapter. Okay?